So in the previous lecture we have seen the impulsive force. So when this liquid is going outside, it is experiencing some impulsive force due to the change in momentum, and that is applied by this vessel. So due to action reaction, the liquid will apply the same equal and opposite impulsive force onto the vessel, and that the value of that vessel we have calculated, that was 2g rho A into H. H is this. This is H. This total is capital H. So now we want to see, due to this impulsive force, what will happen to this vessel, whether this vessel will move and under what condition this move, and when it will move, what kind of friction it will experience. So let's assume for a time being this vessel, the total mass of the vessel is capital M. So and that total mass means vessel plus the liquid inside, and this surface is having kinetic friction, coefficient of kinetic friction, which is equals to mu k. Okay, so if we study the forces applied onto this vessel, there are 4 types of forces which are being applied onto this vessel. First one is capital Mg, which is acting downward. The second will be the normal reaction, and the normal reaction will be acting at each and every point onto this bottom of the each and every point on the bottom. And let's apply the normal reaction here somewhere, net of that. Okay, so and this F average will be acting horizontally, and this F average will act as if it's a driving force, because this force might create the motion. So it will be acting in this direction, and to oppose this force, the friction will be acting in the forward direction. I'm applying the F only right now. Okay, so vertical forces will be balanced because this vessel is not going to go up or down. So I can say the normal reaction in all the conditions are going to be capital Mg. That will be the value of normal reaction. Okay, and if you see this friction which is being applied in this direction, the maximum value of this friction, that will be equals to Fs max, maximum static friction. And as we have studied in the previous chapters, this Fs max, the value of Fs max, we can take it as Fk for all practical purposes. So the maximum friction available at the bottom will be equals to mu k times of n, and if we put the value of n from here, it will be equals to mu k times of capital Mg. That's the maximum value of friction which is available. So this friction will try to prevent the motion. Okay, this is the maximum value of that force. Okay, so there will be 2 conditions. So if this F average is more than Fs max, that's the first condition. If this F average is more than Fs max, which is equals to mu times of Mg, in that case motion will happen. And in that case, if I make the FBD of the system, meaning if the motion is happening, I mean to say if motion is happening, I'm considering that case. So when the F average will be more than Fs max, in that case motion will be happening. So capital Mg will be acting downward, F average impulsive force will be acting in forward direction, and Fk will be acting in backward direction. And since motion is happening, the system will be having some non-zero acceleration. So if I want to calculate that acceleration, this F average minus Fk will be equals to capital M times of A from the second Newton's law. Let's put the values. So it will be equals to 2g rho small a h, that's the F average, minus mu times of capital Mg, and that will be equals to capital Ma. Okay, so in this case the acceleration of the system will be equals to 2g rho a h minus mu capital Mg divided by capital M. But for that to happen, this value has to be positive. So when the acceleration will be non-zero, the friction at the bottom will be equals to Fk. When the acceleration is non-zero, only in that case friction will be kinetic in nature, and the value will be equals to mu Mg. This is the first case when the average force applied due to the impulsive force, and that average impulsive force is more than the maximum friction available. If the average force is less than the Fs max, in that case motion will not be happening, meaning motion will not be happening and acceleration will be 0. Motion not happen, will not happen, and the acceleration for this system will be 0. We'll make the FBD for this system also. The acceleration will be 0. There is normal action, there is capital mg, and there is this F average. But this time the friction will not be kinetic in nature because the acceleration is 0. This time friction will be static in nature, which will be variable. So when the acceleration is not happening, in that case F average minus Fs will be 0, and from that equation we will get Fs, value of Fs will be equals to 2g rho A h with acceleration 0. There can be only these two cases. So in the previous lecture we learned that when the liquid is going out, it is experiencing some impulse because of the change in momentum. So the same impulse the liquid will apply onto the vessel, and that impulse is continuous in nature. So corresponding to that impulse, we calculated the average impulsive force, and that value was this 2g rho Ah. Okay. Now when we see some force acting onto the vessel, we wonder whether this vessel will move or not, because there might be some friction. So we assume there is some friction, kinetic friction. So, and corresponding to that, we made two cases. One case when the motion is happening, and the second case when the motion is not happening. In first case, when the motion is happening, we calculated the acceleration, that will be the value of acceleration. And when the motion is not happening, in that case we calculated the applied friction force at the bottom. Okay. And all this depends upon whether this F average is more than Fk or not. If F average is more than Fk, motion will happen. We have to check that once we calculate the F average. And if F average comes out to be less than the maximum value of Fs, then the motion will not happen. In that case, maximum, whatever is the value of F average, the same value of force will be applied by the friction. Okay. So this is regarding the friction, meaning we studied the friction force corresponding to the height. As the height will change, the friction might change. In this case, the friction is coming out as a function of small h. As the small h value will increase, the friction will also increase. But it can only increase till this value. Okay.